been so kind to give us a talk. And he will be speaking about setting the lower bound of scalar categories, a categorization and error minimization approach. His co-author is,
Sunjin Hong.
Sunjin Hong, and let me see, she is a PhD, sorry, is he?
No, it's a she.
She is a PhD candidate in the Department of Linguistics at the University at Buffalo in the US. And her research interests include semantics, pragmatics, and psycholinguistics. She's currently writing her thesis on the processing of scalar adjectives, specifically tall. And Dr. Koenig got his PhD at the University of California at Berkeley in 1994. He's a specialist of lexical knowledge, semantics, aspect, negation, event semantics in particular, morphology, the interface between syntax and psycholinguistics. He has worked together with colleagues and students on a number of languages and is now working for 15 years on the syntax and morphology of Iroquoian languages together with Karen Michelson. He's co-editor of Head-Driven Phrase Structure Grammar, which will appear in 2021. Okay, thank you, Jean-Pierre.
Thank you so much. I think I can share my screen, right?
Yes, definitely.
Okay. So this is
live. Sorry. Hello, my name is Martin. We're streaming live. The chat is now closed, but we will open it afterwards when the presentation is over for you to either type in your questions or ask to speak.
Okay. Okay, thanks a lot. So this is actually Sunjin's dissertation research, but it's very early in Korea, in Seoul, so that's why I'm the one presenting it. Okay, so I have 30 minutes. So one constant across studies of scalar adjectives is that the category membership involves a vague and context-dependent determination of a threshold. So basically, that means that Martha is tall should be interpreted as Martha's height is greater than a threshold. And the question we are going to be interested in today is, how do we decide which objects among a set of objects, sometimes called the comparison class, are tall? And that amounts to deciding on the threshold, namely the lower bound of tallness. Now, there have been some previous experimental studies, and I will focus on those because our approach is experimental. Some people like Barner and Snedeker and Siret and colleagues have focused on the fact that children understand quite early, by 4 years old or thereabout, the context dependency of the threshold. So namely that depending on the particular comparison class, the threshold will vary. Some have talked about the fact that the distribution of heights within the comparison class affects the position of the threshold. So whether you have something that is approximately normally distributed or skewed left or right affect where the threshold is located. Some have also suggested that the threshold might be due to some categorization into distinct clusters of members of the comparison class, and that will be the perspective we will adopt. There have been also recently quite a bit of computational modeling where people working within a Bayesian or rational approach to the interface between pragmatics and semantics suggested that the threshold for scalar adjective is set to optimize, on average, the communication of the object's height. That was a work from Lasseter and Goodman, but also Chin and Frankie. Now, our approach, as I mentioned, is categorization based, which is that we assume that what speakers are trying to do when categorizing objects is to divide the objects into two categories, tall and not tall. In some tasks, it would be tall and short, but for our set of experiments, it's going to be tall and not tall. And then they have to make a decision on the determination of the boundaries. And therefore, that the determination of the threshold is a categorization issue rather than a communication issue. And we are going to make one assumption and then two hypotheses. The first assumption is going to be that speakers know that tall objects are in the upper half of the scale. So that's an assumption we're making, and actually we tested it. Hopefully I'll have time to mention an experiment on this. It seems to be a correct assumption. And the two hypotheses we're going to make is that what speakers are going to striving to do is to minimize categorization errors. They don't exactly know where the boundary is, but they are going to choose as a boundary that will minimize on average errors. And the second hypothesis we'll be making is that speakers use any additional information than this strive for error minimization to help them reduce uncertainty about the category boundaries. Now, many previous studies have assumed that there is one way speakers set a threshold, and then I've tried to find what is the best way, namely given the experimental evidence that we have, what do speakers rely on? Is it the mean? Is it the maximum height of objects? Is it the median? Is it a proportion of the total number of objects? Do they rely on the shape of the distribution of height? Our view actually is that there is no single way that speakers determine the threshold, the lower bound of tallness. And because of that, it depends partly on the properties of the set of objects they are looking at, but also on the task. So our strategy is to basically control as much as possible all of the variables that could influence a determination of the threshold and study one at a time, one variable. For the experiments we're going to report on today, we basically kept almost constant, and as much as possible, given the real world, because there are interaction between these variables, the median and the standard deviation. And we also kept the distribution constant. Basically, that meant that there was a roughly equal number of objects at each degree of height, 1, sometimes 2. So it's a flat distribution, which is somewhat unnatural for a naturally occurring set of objects in the world. But that's the way we basically wanted to keep everything constant. And we did have an experiment that we were running where we had a different kind of distribution. There, we manipulated the distribution. Unfortunately, COVID happened, so we were not able to run experiments with real people because that's the way it is. So here is the question that we address in this paper. Do large discontinuity in height affect judgments of tallness? Can proportion of objects, is a proportion of objects more important factor in judgments of tallness? I want to minimize you guys. I don't know how to, yeah, better. And 3, whether the way you present objects, either all together or simultaneously, makes a difference in where the threshold is set. And finally, we'll present a cognitive model, which is an error minimization explanation of why, across all of these experiments, participants tend to prefer to set the threshold around the 75th percentile object, okay? Now, given what I said before, it's really important to realize that our result pertain to our control stimuli, where we control mean, median, standard deviation. Once you allow those factors to come in, they might be, the results might be altered in some way. So in the first experiment, we looked at the effect of discontinuity in height on threshold location. And two questions we were asking is whether a large discontinuity in height affected the determination of the threshold, so where participant put the threshold, but also whether the location of the discontinuity also had an effect. So we had 3 arrays of 20 objects that basically people had not seen before, and either the discontinuity, so it was one inch here and 2 inches there, and whether the larger discontinuity occurred between the 40 top tallest objects and 60th bottom objects, 25, 75, 15, 85. Here is what the stimuli look like. So they never had seen these stimuli. They were some kind of plastic round cylinders, and they were real objects that people had to manipulate, and they basically had to put these objects on the objects among that set that they considered tall on this red circle. We follow the procedure from Bardner and Snedeker. The placement and the placement of the objects on the table was randomized across participant, and the order between the 3 array, each one representing a different location for the discontinuity, was rotated across participants so that they could not be, to minimize effects of order of array. Okay. So here are the results. When the discontinuity, you can see here, when the discontinuity is at the 60th percentile, counting from the bottom, so 40th from the top, there is a reason why we use counting from the bottom. We'll see that later. People choose that object, the discontinuity object, more than any other objects. It's even more when it's 75th percentile, but it's also more when it's a little bit less when it's 85th percentile, but still people prefer the 85th percentile. So here is in table form, the number of participants, which shows the discontinuity object was 23 out of 48, 34 out of 48, and 14 out of 48. Okay, so the results when you do the statistics, which is basically either chi-square or Fisher exact test, depending on the test, is that discontinuity matters, but the location of the discontinuity matters too. The participant seized on the discontinuity to make a decision where the boundary was to set the threshold, at least when the mean, median, and standard deviation were kept constant and the distribution were controlled for, but there was also a Goldilocks effect, namely the larger effect of the discontinuity occurred when the discontinuity was located at the 75th percentile counting from the bottom, or the 25th percentile counting from the top. Given that discontinuity matter, we wondered whether discontinuity can win the day and in fact override our assumption that less than 50% of the objects in a compensation class are tall. So the question we asked in the second experiment is, what if a discontinuity is below the 75th percentile objects? Would the presence of the discontinuity still affect the judgment of tallness? And people prefer a percentile that was below the half, the median, because it's a discontinuity. So we had a discontinuity either at the 30th percentile from the bottom, at the 40th percentile from the bottom, and the 50th percentile from the bottom. And in the interest of time, I will skip the results and just give you the lowdown on the results. Namely, the discontinuity was not chosen the most at the threshold when it is below the 50th percentile object, validating our assumption that people assume that the tall objects are above the median. It did affect a little bit the setting of the threshold. So if you look at the people who chose a threshold that was below the 65th percentile, again, counting from the bottom, or 35th percentile counting from the top, there were more people, significantly more people that chose as a threshold object that were below the 65th, when there was a discontinuity at 50, the median or below, than otherwise. So it had a small effect, but nobody chose the discontinuity very much at all, because they understood that tall objects are above the median. Okay, now the second question we asked was, what does 75% mean? Does it mean the 75th percentile of objects, namely the, as I've mentioned, or does it mean the 75th percent of the tallest object height, which is, so is it based on height or is it based on number of objects? And the reason we couldn't decide is in a critical array, these were the same thing. So that object, which is a discontinuity object, was both 25th percent from the top or 35th percentile from the bottom, but also the height was 75% of the maximum height, which is here. By the way, the Barner and Snedeker experiments, which we borrowed from the task, had the same count found. So we wanted to know, okay, do people prefer a percentage of height, maximum height, or percentage of total number of objects? Which one do they prefer? So we conducted a second experiment, well, third actually. It's third. The first one is there was no relevant discontinuity in height. So either the discontinuity, but the large height was either at the discontinuity of the 75th percent of total objects. So here there is no discontinuity. Either this is the object that represents 75% of the maximum height, 75% of the total number of objects or below. And you see there is no discontinuity at that point or at this point. Here there is a discontinuity in the second array at the 75th percentile of the total object, and here a discontinuity of the 75th percent of the tallest object's height. Okay, now the procedure was the same as before. You have a set of objects, you put the object you consider tall within this red circle. Like before, we rotated the placement of objects by participant on the table, and we rotated the order of array across the 48 participants to minimize order effect. And here are the results. So when there is no discontinuity, you can see that they choose this the most. This area, which is the area centered around the 70th percentile. When there is, these are the wrong, sorry. These were the, sorry, it says, wait a minute, these are the wrong results, sorry. So when there is no discontinuity, they choose the interval centered around the 75th percentile object the most, right? So they are not here, they are here, which means if there is no discontinuity, they prefer to base their judgment on number or percentage of objects that are tall, not on percentage of height. When there is a discontinuity at the 75th percentile, it's the same, except that in a sense, the choice is even more skewed toward the 75th percentile if you compare those two distributions. And then when there is a discontinuity at the 75th percent of the total maximum height, there is an increase in the number of participants who chose the 90th percentile, 75% of maximum height, as the threshold, but they still like this area the most, which is the 70th and 75th percentile. So there is a general preference from our participant in experiment 3 for people to choose basically a quarter of the object ought to be tall. That's basically what they prefer. And when there is a large discontinuity height, it can modulate that preference but not necessarily override this preference. So even when there is a discontinuity, the object that corresponds to 75% of the maximum height, people choose that object as threshold more often, but they still prefer the interval around the 75th percentile. Okay? Now, we then ask a third question, which is why do people like discontinuity? Why do they latch on discontinuity? And in particular, what would happen when stimuli are presented sequentially? Now, the experiment, now we ran 3 experiments, but I will only report in the interest of time one. The results from the other don't change the conclusion much. And one thing of note is we are, as far as we know, the first people who ran experiments on scalar adjectives where the presentation was sequential, which is presumably more natural. Namely, we are not presented with all of the trees, with all of the people at once, and then begin to learn which ones are tall. We see a lot of trees, we see a lot of people, and then we progressively make judgments of tallness. Now, the arrays are going to be the same as the one in the third experiment, which is unfortunately labeled 2 here. So no discontinuity of the 75% of total objects, or discontinuity of the 75th percentile, or a discontinuity of the 70th percent of the tallest height, right? Same, but now the presentation will be sequential. So objects will be presented one by one and then removed from view. And then after all 20 objects are presented, we will test people with 6 objects at the 75th, 70th, 75th, 80th, 85th, and 90th percentile, respectively, in one by one in random order. And then for each one of these objects, people will have to say whether they are tall or not. So there is random presentation of objects during both training and testing. So here's an example video. Hopefully it will work.
Okay.
And this is Sunjin.
Okay. Okay.
So that's the presentation. This is, of course, a subset. There were 20 objects, but you get the picture, so to speak, of the movie. And now,
Is this tall?
Yes.
Is this tall? Is this tall?
No.
so clearly this is a pre-COVID experiment. Okay, so now our predictions were that the effect of discontinuity should remain if it's not a simple Gestalt effect, namely people look at the entire array of objects and then scan them and then divide them into tall and not tall. They can't do that since the objects are presented one by one, and then they have to interrogate their memory in order to answer the question. Now, we also make a prediction that the Goldilocks percentile for threshold, which was around the 75th percentile, right, should be slightly lower. And that's due to experiments that have been run in vision, pure in the psychology of vision. And here is a quote from a recent 10 years ago, Brady and Alvarez paper that basically say the remembered size of each individual item in a display is biased toward the mean size of the set of items in the same color and the mean size of all items in the display, right? So the idea is that the size for objects that are higher than the mean will be remembered as smaller than they are. That's the basic conclusion, which is that the size of an object that is then presented visually and that people have to make a decision as to whether it's tall or not will look more different from the mean than it is, and therefore higher than the mean than it is, which is it will correspond to a higher percentile than it actually was in the original array, which should shift the threshold slightly lower. Okay, so that's a second prediction. So this is the results. And for comparison, and I apologize, it's experiment 2 and 3. I didn't know whether we would have time for experiment, what is now experiment 2. So doesn't matter. But so this is the experiment which was presented sequentially for that very same array. And then the experiment 3 is the one where it's presented sequentially. So you can see that people still like the 70th and 75th percentile the most, but it shifted slightly lower. Look at the number of people who chose the 76th percentile object as threshold when the objects are presented sequentially and when the objects are not presented sequentially. There is no effect here simply because the 75th percentile rule the day. There are so many participants who chose the 75th percentile that there is not enough variation outside of that 75th percentile to have a significant effect on a lowering of the threshold. And the same is true for when there is a discontinuity of the 90th percentile, which remember is a 75% of the maximum height. So this is the only one where you find a result because there is not enough variance in the choices by our participant. And as predicted, both people still prefer the 75th percentile objects as threshold, and 2, the choice of threshold is moved down a little bit, okay? So we conclude that the effect of discontinuity is not simply a Gestalt effect of visual grouping. And I want to stress this because it's something that it took us a while for Sanjay and I to realize that this is an interesting effect, namely that discontinuity mattered even though participants could not ascertain whether there was a discontinuity in height among the 20 objects or not until they had seen all objects, since we rotated randomly across participant which object they saw first or not, which means the discontinuity object might be the first object they saw or the last object they saw. They had no way of knowing. But somehow, when interrogating their memory, they kept track of where there was a discontinuity so that it had an effect on their responses when we present objects one by one. One of 6 objects we present after the presentation that was sequential. The second conclusion was that the sweet spot for the 75th percentile is not due to visual grouping of comparison of subset of objects, which was also a worry we had because it remains. People still prefer the 75th, something around the 70th or 75th percentile. And 3, there is an effect of memory. So the Goldilocks interval is shifted somewhat. Namely, 20% of our participants chose a 65th percentile when there was no discontinuity, significant discontinuity in an array, whereas there was 0% of our participants that chose that percentile when the objects were presented together simultaneously. Note that the Goldilocks effect is robust with respect to presentation order and instructions. These were experiment 5 and 6, I think, that we ran. Now, why do people basically prefer to decide that for a new set of objects they see, about a quarter are told? Why is it that this area around 75th percentile is what people prefer to set the threshold at when making a decision about tallness? And our hypothesis is that participants are trying to minimize the chance of miscategorizing an object as tall and not tall. They have a prior belief, as per experiment 2 we discussed, that an object is tall only if it is within the top 50% of height, so above the median. But they have no additional information about the weird, never seen before set of objects that they are presented with that would help them determine where the threshold is. So the rational decision, given they have no prior belief, is to say, which to choose a threshold, the threshold that wouldn't minimize errors, right? They don't know, but they want to be right. So they are going to try to choose the threshold that minimizes errors. But if there is a discontinuity, well, that gives us an additional piece of information, and they're going to use that too. Now, we are modeling error minimization via precision and recall, which is an idea that comes from document retrieval in Spark Jones a long time ago, but that is standardly used in computational linguistics, particularly information retrieval. So precision in the percentage of actually told objects among the objects that are labeled tall. That is, how many of the objects that a participant has labeled as tall by moving them or saying, yep, that's tall, are actually tall. And recall is a percentage of objects that are labeled tall among actually tall objects. So it's kind of, are they objects that are tall that you deem not tall, right? And the idea is the optimal strategy is to maximize both precision and recall. And that's called, that strategy amounts to maximizing the harmonic mean between precision and recall, which is, if I remember, you know, I always have to look at it, it's twice the multiplication of precision by recall over the sum of precision and recall. That's called the harmonic mean. Okay, so when you do that, selecting the top 25 and 25% of objects would on average indeed result in the highest harmonic mean. Pretty much the 75th percentile would be the best, although if you choose the 75th or even the 70th, it's close enough. Anything between the 70th and 80th percentile would be pretty much equivalent, but 77.5 is slightly better. So what that means is, if you choose between 20 and 25% of the object as tall, that is actually, you minimize your chances of being wrong. And if you assume that this is what people are doing, then you can assume that our participants were rational. They basically made the best decision they could, given the task, they had to select the tall objects, and given the lack of information, and therefore the uncertainty under which they were operating. Now, what about discontinuity? Well, discontinuity adds information, and they can use now more information that just, oh, it has to be above the median. And there are two ways you can think about discontinuity. One is you can think of it as a superficial cue, which is Gestalt-like principle of perceptual grouping. That would work well for our experiments where presentation was simultaneous, but not for presentation that was sequential, where people had to rely on their memory. And possibly here, it means that what discontinuity meant that it indexes two distinct populations. So when you have a large discontinuity, it basically, you know, suggests that there are two populations that are distant among the set of weird new objects you are presented with. Okay. Now, the discontinuity don't win the day, as we mentioned, and that's because participants cannot be sure whether the discontinuity is a reliable cue of true category membership. And I'm supposed to hire somebody to design experiments we can run online now that we have COVID and that Sunjin is on another continent I am. And then we could test whether that was the case, whether discontinuity would matter more when the color of objects differs. And there are reasons to believe that this might indeed be the case based on some of the experiments that Brady and Alvarez, but other people in vision have pointed out. But we first has to basically build a piece of software that would allow us to run these experiments on ibex farm. Now, how do we explain the effect of sequential presentation? Well, when there is no discontinuity and participants make judgments from memory, the peak threshold for total is slightly lower between the 65th and 75th percentile rather than 70th to 80th percentile. Well, our explanation in their choice of threshold is a result of two distinct attempts at error minimization. One is minimization of categorization errors, the same as when the presentation of objects is simultaneous, as we discussed. But there is another reason to do it, which is the minimization of memory errors on actual heights of objects. This is work from Janet Huttenlocher, a beautiful work about the fact that people make systematic errors when they have to judge the size of object, when event occurred in a semester for undergraduates, and so forth, because they are not exactly sure of the height, the actual height of object they have seen. And the best way to minimize error when you don't really remember the actual height is to move your decisions toward the mean, right? She explored that in a Bayesian framework, but you can choose your framework of choice. So there are two error minimization, one about categorization, and one is you're not sure what actually was the height of objects you have seen. So you move every decision downward, because the mean is, of course, a central tendency of what you have seen, and therefore you are minimizing your chances of error by moving your decisions toward what was the central tendency of the distribution you saw. Now, we want to conclude with something that is well known since Aristotle, as I pointed out to Sunjin. He is the first person to basically notice in this, because he was a logician, in the discussion of contraries in contrast to contradictories, that pairs of scalar adjectives like short and tall do not cover the entire scale. And the suggestion we want to make is that fact is actually not possibly the result of a semantic constraint, so properties of the meaning of tall or the meaning of short on where the threshold for short or tall is. It might be the result of people's attempt to minimize errors when determining which of a new category of objects are tall or short. In other words, we don't view the determination of the lower bound of a scalar adjective like short and tall as part of the meaning. We view that as a result of their people's attempt of minimizing errors. And I think that's it. Oh, no. If you are worried that height do not figure out at all in the where the threshold for scalar adjective is located, you say, well, that's kind of weird. Remember that the distribution of our stimuli was flat, which is pretty much if there was the same number of objects at each degree of height, which is totally abnormal in the real world. The typical distribution of height is normal, like the typical distribution of grade is normal. And our suggestion is that the effect of mean height on threshold actually is due to is a distributional effect, because of course the point of a normal distribution is that the mean is the peak of the distribution. And we are currently testing this hypothesis, and we have been currently testing that for 9 months, because literally the experiment was in the lab in March and the lab closed. Thank you.
Okay, thank you, Jean-Pierre.
So let me try not to, should I stop sharing?
Yes, but you might be asked to go back to the slide.
Okay, well then
Right.
I will stop sharing. I don't know where I am. Clearly, see, I was teaching live, so I didn't have to use Zoom that often. So I'll keep that up. But then somebody needs to tell me, you know, who wants to talk.
Yes, I mean, we have a chat, and people write in that chat that they have a question. And
Oh, okay. Okay,
so, and Martin is dealing with the chat, so he's in charge of deciding who will ask the question or not.
Okay. So somebody whose name is Posgrado Educación.
Yeah, me. That's me.
Okay.
Well, I have a number of questions. I mean, I really like the way you said an experimental approach to this kind of semantic problems. And I mean, I'm not really familiar with the topic, so my questions will be really naive, probably. But as far as I understand, then your results tell us that statistical thinking is more important than the actual properties of the objects, right?
Yeah, right. Now, yes, that's but that's for the threshold, right? Now, people, so people have asked, well, what if they were known objects, right? And it's a really interesting question. And in fact, Gail, who will be a co-author on the written version of this, has always said, well, why don't we run an experiment on figurines of actual things? And at least our answer was, well, the problem when you do that is if you imagine you have people, you have trees, you have buildings, what have you, is then people are going to bring to the task whatever beliefs they have about heights of particular groups of people, groups of building and so forth, and we don't control that, right? and therefore we have no way of interrogating. So we decided to start with something that was visual, because there is lots of literature on this, so, and which is also the best perceptual dimension. That's clearly the one that's favored by humans. That we have a lot of knowledge from the vision literature, and where the objects are unknown prior to the experiment, so that there is no contamination of prior beliefs people have, and then we can go on from there.
Okay. And do you think that you can transfer your result to other kinds of scalar adjectives, like good, for example, that are not visual?
Yeah. Well, Sanjay had a brilliant idea. Unfortunately, and I'm smiling because that was something that we began, and now we'll have to see. Whenever I'm done proofreading the handbook of HPHD, I'll have a little bit more time. She wanted to do that on still perceptual, but on addition. And the reason is Sanjay and had an idea, and I think she's right, that prior belief about negativity or positivity has an influence on threshold. So the idea was to present sound that are either that we would have norm, that have pleasant or unpleasant. It could be perfect chords versus tritones, for example, in music or what have you. And then have judgments of loudness. And the idea was that loudness threshold would actually be affected by whether the tones or chords or melodies were labeled by another set of people as pleasant or unpleasant. So that's the next step, because it's still perceptual, but in another dimension, where we replicate the results, hopefully, for neutral, and then with a little bit of a twist, depending on the connotation for us, I mean, whether it's pleasant or unpleasant. The problem is we need to read the entire literature, well, not the entire, but a significant portion of the literature on auditory perception. And we spent a little bit of time when I was on sabbatical, because I had more time, discovered all of this literature, some of which I owe to Adele Goldberg, because she had a colleague who, at Princeton who was a specialist of visual perception. But I don't know the literature on auditory perception from cognitive psychology. Fortunately, we are thinking of collaborating with a specialist of auditory perception, Peter Ferdrescher, and of music cognition at Buffalo. But he sent us tons of things to read. So that's for this summer. I'm hoping this summer I'm hoping to read all of this, and then we can design the experiment. But the advantage is that the technology, right? All of the synthetic or whatever and he can do in his lab, basically, because we don't have the equipment either to do it, controlling perfectly, pitch and whatever. You need somebody who does auditory processing, and that's not us. So, and then we can go onto the fun one, the good.
Right. But you mentioned during your presentation that you suspect that color, when you add color to the stimuli, things might be affected. I mean, the judgment might be affected.
Yeah, for memory, because
Okay.
because people in vision have shown that this tendency to go toward the mean is right. So basically, where you minimize error from the fact that you don't quite remember the actual height of the objects you have seen, and therefore you say, well, if I go toward the mean, I'm going to have less chance of error when I do my response. That effect seems to be changed if you have the objects that have different colors, then they don't group them together. So the idea that I had was to actually play on this because of this effect from vision. And this is, by the way, a way you discover when you are a poor linguist like Sunjin and I running psycholinguistic experiment that unfortunately you can't escape psychology, right? Regular psychology. And namely, you have to read the vision literature.
Right. And your speakers were all English speakers?
Yeah, they were native speakers of English as far as, that's
okay.
I mean, as I said, for weird reasons, I have some amount of money, and my plan over the break is talk to Sunjin and see what kind of a piece of software we want to build so that we can run experiments online, which would be clearly the way to go, because we have X number of experiments, but we don't have access to a lab. She's in Korea and here, it's complicated.
Right.
The only problem we have is because it's vision, I'm always concerned about pixel size, right? That is, some people might run these experiments on cell phones and some of them on desktop. And does that make a difference? You see what I mean?
Yes, definitely. Yeah, that will change the stimuli.
Exactly. So now the way to do it is to basically build, have a way of interrogating the source, basically, so that we gather the pixel size on which they saw it, then run one of our standard experiment and see whether it makes a difference or not, and then correct for it, basically. That's a way to do it. With the recent statistical technique, we can do that. Now, somebody called Gisela asked about the width, and that's a very good question. One of our co-authors for some of these experiments, Gail, has always said, width, ratio of width to height matters. Absolutely. And that is one of the 20 variables. That's why we really need to, as I said, I need to spend the money. Well, more importantly, I need to find the right computer science student to build the interface so that we can run these experiments for cheap online, because you're absolutely right that in some sense, generally our perception of tallness, again, that's a visual thing, is affected by the width to height ratio. Absolutely.
Thank you.
Yeah, absolutely. You're right on. And as I said, the sky is the limit. The bizarre part is, if you and correct me, Sunjin, if you are wrong, if you consider the number of people that have run experimental experiments on scalar adjectives, right? I know of 1, 2, 2, 3, 4, 5, I think 5 or 6 groups I've ever run experiments on scalar properties. So there is 20,000 variable that people have not explored, And many of the previous people in the literature did not pay attention to the way in which variables are related. So Gertzner and Stolz, and Gertzner is still doing it, Stolz does other stuff now in Germany, they ran really interesting experiments where they manipulated the distribution, whether it's normal, skewed, and so forth, but they did not seem to have control for mean and median. And we know, well, Sunjing knows, for having tried to construct stimuli, that of course, when you vary the distribution, you vary where the mean is located. That's the point. So it's very hard to know then whether the effect is due to the fact that you have moved the mean or the median, or the fact that you have actually, it's the shape of the distribution that matters, right? So yeah, so there is a lot of experiment you can, and that's for one perceptual dimension. Then you have to the other ones. The only other one that we seem to be really good at is auditory perception. Although my favorite would be stink or smell nice. And I imagine an experiment where you vary the degree of stinkiness. That could be fun.
Right, right. Hard to run.
Hard to run.
Yeah.
Hard to get, and depending, we have to worry also about, not inflicting harm on our participants. So
right. You could do it with wine,
That's a good point. Yeah. No, but I think that,
tasting.
absolutely, and so there is a lot of interesting stuff. And the question that is interesting, that the person we are going to try to collaborate with running experiment on auditory perception, is he asked us the question, well, are you interested in the categorization, or are you interested in the relationship between categorization and linguistics, right? And we are interested in the relationship between the two, because you can run an experiment on vision, you can run an experiment on auditory perception, where people's responses of similarity, dissimilarity, and loudness, whatever you want, but that's not what we're interested in. So you need to know how people process perceptual input. But then we are interested in the effect that labeling has on the categorization, right? We're not interested in the underlying categorization of percepts. We are interested in the effects on the categorization that labeling has. So.
Right. And I don't know if there is another question.
I think that there is a question from Pascual.
Hello, can you hear me?
Yes.
Yeah. Well, in the first place, fascinating experiment. I have questions from linguistics and semantics. My experience of experimental psycholinguistics is very, very limited, very poor. So I won't be able to contribute much to that aspect. However, there is one thing. Would you say that the relationship between the stem and the base of the objects that you use may have had an effect, a visual effect? Like, apart from the discontinuity and so on and so forth. For example, in some cases, it's obvious that the stem, in comparison with the base that supports it, is tall. But in some cases, I don't know, in a different context, maybe the stem may be perceived as relatively tall if the base were smaller. I don't know if you thought about it. Just
That's
occurred to me.
Yeah, and unfortunately, yeah. Yeah, I mean, the only thing I would have to say is we felt guilty, and it's really bad that what do you call it, that that COVID occurred, because we had access to lots of participants who were free
Oh, I see.
And they really loved our experiments, that Sunjin would tell you, because she's the one who ran the experiment, of course.
Mhm.
And because these experiments they were getting credit for very short experiments compared to that of our colleagues.
Yeah, yeah.
We almost felt guilty. The problem is, okay, so now we are going to go online. And
Mhm.
online, well, every experiment is about 48 participants. So if it's about 15 minutes, it's not too bad, because basically, it's $10 or 11, let's just say $10 to round up, $10 an hour. So it's about $140 for each experiment. So that's not too bad. The only thing I would say is that the only thing I would say is, okay, after a certain number of thousands of dollars, so we'll have to be a little bit careful. One of the advantage, of course, now that we're going to run it on the screen, the problem, of course, the screen is that people construct this 3D, but the advantage is they can be, in space. They don't need a base. They don't need a base.
Yeah, exactly. Yeah, but yeah, and then of course, your presentation set me thinking. Scalar predicates are, one of my favorite subjects, but from an abstract point of view.
Yeah.
So along the lines of Luis, I have, these are not criticisms, but just suggestions and questions. I was wondering if you would like to work with, say, more subjective adjectives. Well, you mentioned good and bad and so on and so forth. In the original literature on scalarity, people, even in the 70s, made a distinction between object-related gradable adjectives and subject-related. And, something one read was, the largest mouse will always be smaller than the smallest elephant, things like that. So I was wondering if you are planning on introducing, in your experiments, comparison with objects, having different objects. I know that it's probably difficult to introduce many variables into
Right, exactly. So
But-
yeah.
these are just ideas, questions.
Yeah, so no, absolutely. So the next step is to generalize it to another perceptual dimension and introduce the possibility of affect. So whether some percept is pleasant or unpleasant in the judgment. Once we understand that, for example, people have suggested, so Jonathan Ginsberg has suggested, hey, why don't you do quantifiers like, many to see whether, yeah, but again, that makes it more difficult. I know that Sunjin initially wanted to test the effect of affect on threshold, on where people put the threshold with expensive or cheap. The problem, of course, is that is going to partially depend on the income of the people coming into the lab. And
Okay.
and even though undergraduate students to some degree have a similar income, their parents don't, and we don't feel necessarily comfortable asking them, well, so how much do your parents make a year?
Oh, I know. Yeah.
Because so that's a problem oftentimes for things that are that have a evaluative component to it. We are tapping on a variable that we have to be sure how people react. Now, there is stuff that we could potentially use, these people who do implicit bias kind of experiments where they present words and, to see how they group it or what have you. And that might help, because that lead to another scale, which would be, where we could say, well, this is how much people are affected by that kind of variable. but then that introduces complication. But yeah, ultimately that's something we need to do because and I forget to say that in sometimes Sunjin or I say it whenever we present this kind of experiments. Ultimately, the fact that actual height doesn't matter as much is not as surprising because if you think about it, for most scalar adjectives, we don't have actually any metric, implicit metric, right? So for most scalar adjective, there is not a metric. So there is one for adjective related to time, so old or young, to auditory perception, to visual perception. But lots of adjectives, there is no metric. So the best you can do is either have an indirect link to something that has a metric or rely on percentage of objects, because that's the best you can do.
Yep. And then again, from a linguistic standpoint, I was wondering how you would manage, say, scales that have more than 2 terms. So I was thinking about temperature. So you have cold, hot, but you also have cool and tepid or lukewarm.
Yeah, absolutely. And you're absolutely right in the
I think you mentioned that in the penultimate slide.
Yeah,
and correctly.
Right.
Yeah.
And in the lexical semantics literature, people have made the claim that for temperature, we in fact don't have a single scale, we have 2 scales.
Oh, okay.
Yeah. So that people have a scales of coldness and people have a scales of, Chuck Fillmore has made that claim based on work by Cruz. And yeah. So so we thought of putting participants in the cooler or heating up people in a sauna, but I don't know. That seems difficult.
I know. And then again, finally, in connection with this, some scales have so-called elatives. They used to be called polarity double. I can't remember the name anyway. So, for example, we use a morpheme in Spanish, which is altísimo, which doesn't mean very tall, as is often thought, but which means extremely tall. And sometimes you have an adjective, especially in the case of subjective adjectives like wonderful. So, small.
That's actually,
big, small, and then gigantic, along those lines. That would be also interesting to
and that is actually a very good idea. Thanks. Because what we could do is start with what do the results look like if we just do start with vary, how much do people move the threshold for vary? And we'll have to think about the hypothesis or the prediction we would make, and then go to these weird ones, where the superlative means extremely, basically,
Yeah.
That's
well, thanks again. Very interesting.
No, thank you.
Martin?
There is a question from Carolina. She left, but we can still read the question and discuss it.
Okay, sure.
She says, when you presented experiment 3, you mentioned that people tend to remember the size of objects as the mean of all objects in the display. I am not familiar with the literature on this topic, but I was wondering if you have run the experiment by interrogating participants about the lower boundary in height. Would it work in the same way, with opposite effects, of course? I believe this would provide further evidence about the Gödel effect.
That's a great question. Yes, that's our prediction. So our prediction is that if we were, so there have been a couple of experiments, less than on short. So Barner and Snedeker, they were interested in kids. Barner is actually both Barner and Snedeker tend to have a big part of the research program is in children cognition and psycholinguistics. So they ran the experiments for both short and tall. And it's clear that we make prediction for short, and we make prediction, and that's a great idea. So Sunjin, one of us will have to remember, and you are younger than me, and even though I take notes, anyway. So we make the prediction that if we run a comparison of simultaneous presentation of objects when making a decision about shortness, which objects are short, move them here, or with a mouse, versus a sequential presentation where then we ask people after all of the objects have been presented and removed from visual perception. For some objects, we ask them, is that tall, what have you? We make the prediction that people will remember the object as taller than they were, so that they will move the threshold upward. So, if the threshold is around, the 25th percentile, it will move to the 30th percentile. Absolutely. That's a prediction we're making. And that's an easy one to test. Absolutely. And that would be beautiful until we might, except if we don't get the results we predict. But yes, absolutely. That's a great question, and thanks a lot. Is there a way for me to I know there is a way, but if Martin could save to a text file that the chat, and then send it to me or something like this, because then I can credit you for thinking of that experiment.
Yeah, it's Carolina Atei.
Yeah.
So
Okay. You mean?
I can copy the question and send
exactly,
it to your
because
mail.
because partly because that will help me remember it, but also I can credit. I put her name down, but I think it's a great idea. As I said, right now we need to build the software so we can run it during COVID, and then but that certainly should be an experiment to run soon. Yeah.
Now, Jean-Pierre, if I have one more minute. So if I understood correctly, your assumption is that the acquisition of scalar adjectives presupposes the establishment, to establish this threshold, you need to sort of incorporate a prototype. And memory may play tricks on that, as you mentioned. And again, that prototype may change with experience. It may change, it's a dynamic thing, and it may change with context, cultural context, the more immediate context, the social context. So it's kind of an evolving thing. So the acquisition of these adjectives, I guess the more subjective the adjective, the harder the acquisition. So is that your assumption, or
that's my assumption? Although we
did I get you?
So we didn't test that part. In a sense, it's a good question about acquisition. I'll have to think about it because, in a sense, what we are saying is when we hear tall, we realize soon that the tallest object is going to be there, right?
Yeah.
And we move it, and we basically, so the tallest object is there. The dimension is basically scalar. That's just due to visual perception. Height is a scalar property, irrespective of language. And then we know that the top of the scale is going to be tall because we observe that. And then we don't know anything else. And then the assumption is, okay, let's have as a cutoff when you go downwards on the range of height. Let's use as a cutoff the place which is which on average means that I will make the minimum amount of error. So that if I say Martha is tall, that I don't know where the boundary ought to be, but I know that if I put it here, on average, I will make the minimum amount of error given anywhere where the boundary is. That's the idea. So the idea is that you don't know where the threshold is. There is nothing in your semantics that says where it is, except it's a top half. And except from that, you put the threshold pragmatically where the number of errors when you speak or when you are asked to categorize, like in our experiments, you will make the minimum number of errors.
Yeah, that's
so you know, okay, so let me show you this. This was done, it's a grad student of mine who has literally disappeared from the surface of the earth. I don't know where he is, but I don't know, it's like scary. So this is whether, so he basically, it's a little program and you compute the average value, and here it's on 40 objects, so basically divided by 2, and you can see this is the maximum, this is the apex. And you can see that, so this was done by, I told him, here's the way you should do it. So assume any possible distribution of height. So, you know, every object is tall, half of the object are tall, the top 25, whatever, that's a reality. And then assume people make their cutoff here, right? And then across all the possible actual tall objects that you don't know. And then you run this, and this is the average F value. And when you are here, which is, here, which is slightly above half, so slightly above 75%, this is a 77.5 percentile. That's the way, that's the assumption we have. Now we are assuming, given that 4 years old or 5 years old, it's an interesting question whether 4 or 5 year old would behave the same. So there is data from Barner and Snedeker and Siret and colleagues that suggest they learn pretty quickly, but I have to look at it, but their stimuli were a little bit simpler than ours. So I don't know whether children would do as well as adults on our stimuli. That's a good question.
No, my prediction, sorry.
No, go ahead, Luis.
No, that my prediction would be that in these cases, you know, mommy comes and tell you this water is cool or this kid is tall. So somehow the threshold is given by your mother, so to speak.
But that's an interesting point, which is, that's a good question. Whether in some sense, all you do is mirror what your parents do, so to speak.
The
good part is I don't have to worry. That's not my problem, right? I mean,
right. No, but it's a good question about language acquisition. I mean,
absolutely.
It's like, you know, you go statistically looking for the meaning of words, or you are, so to speak, given the norm.
No, that's a good question, and I don't know. That's a good question. Right. That's beyond my pay grade.
Now, in any case, I would assume that, you know, the whole conceptual structure, the whole conceptual apparatus is innately given. You know, of course, you know, you need input from the environment that is absolutely necessary and that is indisputable. But unless you have something to go by from the start, you know, acquisition of all of this, which is so complex, would take forever. And yet it doesn't take forever. So as an innatist, you know, I find all of this, you know, evidence in favor of, you know, whether you're a cognitivist, you know, whether you follow Lakoff or Chomsky or whatever, I find that some very basic concepts and, you know, the structure of scalarity, et cetera, has to be built in from birth, or else, you know, acquisition would be chaotic each person would acquire things differently. It would go wild, you know, one group going in one direction, another group going in another direction. So I think that, you know, the uniformity that we eventually see in acquisition, I think points in the direction of innatism. You know, whether it's, you know, forget about Chomsky, forget about universal grammar, but let's focus on, you know, the cognitive structures behind the semantics. I think that there's got to be something.
Well,
It's got to be empirically proven, you know, which is very hard. But
well, that's where,
that, you know,
right, and that's where, well, and maybe that we can do when we work with this music cognition specialist, which is on sound, which is so where we compare categorization without language and categorization with language. So how people can categorize tones or melodies or what have you, when we design experiments where they don't have to use language versus when they have to use language. This has been done a little bit by Kay and McDaniel for colors, where they looked at variation in color categorization for tasks that involve language versus tasks that did not involve language. So we could do the same, right? Which is devise a categorization. So our categorization task involve language, right? People had to say, well, is that tall or not? But maybe we can devise an experiment where people categorize, but they don't use, we don't use language and they don't use language. They just do a categorization task from which we can infer where the threshold is, but they have not used language. That would be fascinating. That's going to be there. The trick will be to be very clever in the experimental task. And that's where collaborating with somebody who is a cognitive psychologist, in this case, it's auditory, could be a visual perception, but somebody who knows about how to run categorization tasks that do not involve language is critical, because I don't have, you know, I always run experiments with language.
So mind you, I'm not talking about linguistic.
No, I understand. I
Innate,
really understand.
Universals, but precisely conceptual and cognitive. You know, because if you come to think of it, you know, lexical semantics, as we once pointed out here, is much more complex than syntax. You know, syntax is simpler. Syntax is just.
Yes.
Do you agree?
Yes. As a lexical semanticist of sorts, I tend to agree. But but I think that there are many. You know, it's a little bit. It's interesting. Morphology is pretty darn, particularly.
Morphology
can be pretty nasty too.
You're right. But you know, we both attended Pustoyevsky's class last year.
Right,
remember? Right. And so this, you know, we both agree that the lexicon has to be, you know, addressed in full, and that it's not simple at all. That we cannot relegate things to LF or the interface as hardcore Chomskyans do. So anyway, food for thought.
Thanks a lot, guys. And this, by the way, a couple 10 days ago we gave a talk in Frankfurt. So it's interesting to me how COVID has allowed us to develop better pieces of technology that will allow us to have more talks with more people across the world.
Yeah, true.
Yeah, definitely.
Yeah, look at the bright side of things. You know.
That's right, because, you know.
Let's make the most of COVID.
Yeah, that's right. Okay.
So thank you very much, Sunjan.
Thank you, Jean-Pierre.
Jean-Pierre.
Thank you.
Thank you.
Thank you a lot.
Thank you.
Thank you.
Thanks a lot. And then and then see you sometime.
Okay. And thank everybody who attended the talk and who has been attending the talks of this Círculo de Lingüística. So we might be keep going next year. We'll see. We will let you know.
Felicidades a
Jean-Pierre.
todos, ¿eh?
Yeah,
Happy holidays.
Happy
New Year.
Felicidades.
Bye-bye.
Ciao.
Bye.
Ciao.
Ciao.
Bye.
Everyone.